For this lesson, we're going to learn about hypothesis testing for the mean with the population standard deviation known. The next lesson that we're going to do is hypothesis testing for the mean where the population standard deviation is unknown. So just like in chapter 6, if the population standard deviation is unknown, it's a t, and if the population standard deviation is known, then it's a z. So that's going to be the only difference between these two sections. And we should already know the difference between z and t because of chapter 6. Just to remind you, when the population standard deviation is known, it is a z. So the first step we need to do is that first step, verify that the population standard deviation is known. That's the most important part. The other two parts will always be true. We state the hypotheses and label the claims. So I'm going to stop right there. So number 1, employees at a construction and mining company claim that the mean salary of the company's mechanical engineers is less than that of one of its competitors. So right now I'm going to stop and write my null and alternate hypotheses because I see a symbol there. So is less than. Oops, sorry about that. So we see that in the problem it says is less than that one of its competitors, which is $68,000. The strict inequality goes in the alternate hypothesis, and it's $68,000. And that is the claim, because the company claims. So that is going to be our claim. So my null hypothesis is the opposite symbol with an equal sign. We know already that it's going to be a left-tail test. And because it's less than, it's going to be a left tail test. And we're going to find a critical value eventually. So a random sample of 20 of the company's mechanical engineers had a mean salary. So this sample has a mean salary of $66,000. Sorry about that. Stop writing. 66,000 and a mean, should say, I forgot to type in population. Mean. Oh, never mind. It's there. Sorry about that. So assume the population standard deviation is 5,500. That's where we have to have the population is 5,500. Because this is sigma, it is going to be a z. At alpha is equal to 0.05, so that's our 0.05, test the employee's claim. So my critical value is found with the inverse norm of 0.05. Since it's on the left, the critical value is going to be negative. So I just did a couple steps without referring to the actual steps. So step 1, verify the population standard deviation is known. That's so that we can have a z. We state the hypotheses and label the claim. So that's step 2 in here. Step 3 is that I find the critical values and rejection regions based on alpha. And remember, you use, sorry, my hand keeps touching the bottom, the inverse norm of alpha. Or if it's a two-tailed test, alpha over 2. So we just did step 3 right here. Step 4 is to compute the test value. So this is what I kept referring to, that we're going to do some math. This is the test value, or what's also called the test statistic. So it's some test value, and that formula should look very, very familiar. So z equals the mean, sample mean, which is 66,000, minus the population mean, which is that mean up here in the problem, divided by the population standard deviation divided by the square root of n. Usually I do the top and then I do the bottom and then I divide, and you would get negative 0.89. So this is called my test statistic, or my test value, whatever you want to call it. So we see where our test value falls. So on this number line, remember that 0 is in the middle, negative 1.64 is that z, and then we're going to see where negative 0.89 falls. Well, negative 0.89 falls somewhere in here in the non-rejection regions. I don't care how close to 0 it is. It doesn't have to look like it is, but I know that it is in the non-rejection region. It's in the non-rejection region because it's in the not shaded region. Since it's in the non-rejection region, our decision is do not reject the null hypothesis. Because it's in the non-rejection region, we do not reject the null hypothesis. And then there is not enough evidence to support the claim. So because the alternate hypothesis is the claim, then we talk about support. Because it's in the non-rejection region, we do not reject the null hypothesis, and there is not enough information to support the claim. And I should have labeled those. So that was step 4 to find our z. Step 5 is to make your decision, which is right there. So if the test value is in the rejection region, then you reject the null hypothesis. If it's not in the rejection region, you do not reject the null hypothesis. So we're going to go through a very similar thing for number 2. We know that, we know that we do h sub 0 and h sub a and mu and mu. So a researcher claims that the mean cost of raising a child, blah, 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 is $13,960. So it claims it is $13,960. In a random sample of 500 children and a mean cost of $13,725. Assume the population standard deviation is 2, 3, 4, 5. Again, because this is a population standard deviation, we use z. So that's our first step. Our second step is to draw the sampling distribution. So that's based on the alternate hypothesis. Well, we have the null hypothesis is equal to, and that is the claim, because it says it claims it is. So my alternate has to be not equal to, because it doesn't say anything about greater than or less than. Because it's not equal to, this is a two-tailed test. Remember, this test is based on the alternate hypothesis, no matter which one is the claim. Alpha is 0.010, so each of these tails is 0.005. So to find this, we do the inverse norm of 0.005. I get negative 1.64, but I also need a positive 1.64. So remember, we find that z sub 0, that is the test statistic. I'm sorry, that is the critical value. And it's found with the inverse norm of 0.005, and that's 1.64. Negative 1.64, but we always need the positive and the negative if it's a two-tail. So on your next test, you're going to have some multiple choice, and it might just say find the critical value or find the test value. But then there's going to be problems where you have to go through all of these steps. Show your work. Some of you didn't show that much work on your last test, and I couldn't give you partial credit because I didn't know what you were thinking. So the third step is to use our formula to find the test value or the test statistic. It's the sample mean minus the population mean divided by the population standard deviation divided by the square root of n. So we should get negative 2.24. So that is our test value. We see where it falls on this number line. Well, negative 2.24 is definitely in the shaded region here. So since it's in the shaded region, our fourth step, the decision, is to reject the null hypothesis, because this part in here is the rejection region. So any of the shaded parts are the rejection regions. The fifth step is to make our conclusion. So there is enough evidence to reject the claim. We write reject here because it says that the null hypothesis is the claim. So we write reject. Also in the problem, it says reject. Is there enough evidence to reject the claim? See, the one up here, it just said test the employee's claim. It didn't say see if it supports it. But sometimes it'll say see if it rejects it, just like this one. So those are all the steps. You are going to have to go through all the steps like that on your next test, like I said.